something else I try to do with my students as part of this journey to really understand what it means to be human, um, is to really tie together mathematics with philosophy and history. And it's an interesting oddity almost that most people, even mathematicians that I've encountered, don't really understand or even have knowledge of some of the most recent, not even very recent, but recent events in the history of mathematics. And what I'm referring to is the what is oftentimes labeled as the foundational crisis. So the world of mathematics experienced a foundational crisis. What does that mean? Just in short, for many years, the foundation of mathematics was Euclid, the great geometer of ancient Greece, who said, "This is the foundation of mathematics." And most people listening to this would recognize one of his thoughts in his work as this foundation of all geometry and therefore mathematics was this idea that two parallel lines never meet. Two parallel lines never meet, right? And to some degree, you could say that that was one of his postulates. It's not actually how it was worded, but we'll go with that for a bit. It was certainly a foundational concept within his book upon which everything was built. And most people would listen to me and say, well, yeah, of course, two parallel lines never meet. No kidding. Well, if you start to change things, if you start to look at things differently, as people did in the middle 1800s, they started to realize that there were other possible geometries that didn't make that assumption. So you could
Hmm.
have a geometry where parallel lines, where you had one way of saying this is that parallel lines could meet. Or you could have other possible geometries that you could have through from a given line, a line passing through another point, where there would be many different lines that could be parallel to it. So you ended up with these strange geometries referred to as non-Euclidean geometries that turned out to be completely contradictory to Euclid, but equally valid, completely equally valid. And so Euclid's whole geometry as the foundation, it's not like everything about Euclid was suddenly wrong, but it could no longer serve as a foundation for mathematics. This is the foundational crisis. So mathematics no longer had this rigorous, rock solid foundation of truth. And that's the way that Euclid's work called The Elements was looked at. It's like, this is where how many times have you heard this? This is where we know pure and certain truth. It's mathematics. We know pure and certain truth, right? And then suddenly we didn't have a foundation. This was a horrible thing. And mathematicians, we're talking about 120 years ago, around the turn of the 19th going into the 20th century, there was like all out war. And it was ugly. And there was this huge philosophical debates about what we could do with this. And for the most part, the majority of the mathematicians at that time they were on the side of logical, you could say formal mathematics. What is formalism? Formal mathematics. Well, that's where everything has to have a logical step-by-step proof, similar to what the ancient Greeks wanted, right? Everything has to have if you're
Right.
not proving things, and some of you may be familiar with this, you can go to university today, and there's still this mentality that the only kind of real math is formal math. If you're not proving things, you're not doing real math. Right? Well, you can kind of tell the way I'm talking about it. I don't believe that. It doesn't mean I don't believe in proofs. I just believe there's more to math than just proving things. And so you had, in this foundational crisis, the majority of mathematics at that time were certainly, you could say they were logically based, which are the formalists, the logicists, where the new foundation has to be logic, right? The formalists, well, as I just explained, it's all about proofs and stuff like this. But then there was a small minority of mathematicians, and guess what they were called? The intuitionists, who were just like, no, the basis of mathematics is intuition. Really interesting thought. And they were like the hecklers at the back of the room, right? And it was getting pretty ugly. Which side of the fence are you on? And what was fascinating is, there was Bertrand Russell comes along and he says, well, here's the new foundation. There's a whole, I'm cutting the story really short. And he says, okay, I've figured it out. Here's the new system to replace Euclid, and it's based on logic and all this. And then a guy named Kurt Gödel comes along and he basically proves that that whole approach is wrong. It's mind blowing. And Kurt Gödel, and very few people really understand it. I'm not sure that I understand it fully. He comes and he says, you know what? Our method of doing mathematics, specifically the whole formal idea of proving everything, is not that it's wrong, but it's limited. And in essence, in the end, he says, we can't have a perfect system. There's no such thing as perfect mathematics. I said that wrong. He believed he was a Platonist, as I am as well. So he believed mathematics is out there in the non-material world as this higher truth of beauty. And we as human beings can only imperfectly apprehend and comprehend what's really going on there. Right? And Gödel says our formal mathematics that we said was what math was all about is limited. And so in some ways he was siding with the intuitionists in the end, that the real basis of mathematics is more than perhaps what we as human beings can really wrap our minds around. It didn't mean that mathematics ended, but what it does mean is the way we had been thinking of mathematics, that idea and this quest for perfect certain truth was over. And so I bring all that about because if I look at this more philosophically, what's really needed? Now, it's fascinating to say that this foundational crisis in mathematics happened at the same time as a foundational crisis in science. I think it was, and I'm not an expert in this, but it was the ultraviolet effect or something, some experiment within the world of physics that eventually led people to realize that Newtonian mechanics, the laws of Isaac Newton, were not valid in all situations. And out of that crisis of science came these two new studies that most people at least have heard of, which is relativity and quantum, and Max Planck and Einstein and all of these ideas that came. This new kind of science that violated the previous science that came before with Isaac Newton and all of this. We needed something more than what came before. And so there's this new kind of thinking that's demanded in the world of science, a new kind of thinking that's not just the old thinking. Now, the old thinking was the thinking really dominated by Greek, logical, concrete, black and white thinking. And it's not like that old thinking is no longer valid for any reason, but to really make further strides in our world today of math and science, there's a new kind of thinking. And I have a little bit of a hard time saying what that thinking is, but I'd say that it is more intuition based. It is relativistic. It's paradoxical, that sometimes you need to think of, for instance, with parallel lines. Do parallel lines meet? Well, in one way we can think they never meet, and the other way, well, they could meet at infinity, and it depends how we look at it. They're both part of the truth. And so it's a new kind of thinking that's needed today that isn't rigid, it's flexible. And I think that's part of the problem in the world today. I think we are getting stuck in this rigid old kind of thinking, and we need to become more flexible in so many ways in the world today. And that's what I'm hoping to develop a little bit with our students. And so part of what I just said, I spent a lot of time with my students in 12th grade, really bringing them this foundational crisis and this philosophical realization of what is needed in the world today in terms of thinking. And of course, top scientists and mathematicians, they know this to some degree, even if they don't know the history of it, right? And the truth is, most of our world is stuck in an old kind of thinking. And I'm not patting myself on the back and say, I've got it all figured out. That's not what I mean. But I do think we're living at a very exciting time. And yes, we still need to think logically, but I still think we need to be open and find ways to be open to new ideas through our intuition, which is different than just being convinced that something's true through our feelings. It's a very different world, and getting sucked into believing narratives and all this other sort of thing.